So we're going to go over a specific type of power series. So it's just another one to be able to recognize, and it's based off this function 1 over 1 minus x. So we're going to set up the Maclaurin series for this one. We're going to find the first 4 non-zero terms and the general term, right? So we know the drill by now, right? We're going to find, right, we got f of x is 1 over 1 minus x, right? And I'm just going to make like a little table here. So like if x is 0, right, f of 0 is 1. Okay, so we got our derivative, right? And I'm just going to quick rewrite this. This is just really 1 minus x to the negative first power. So f prime, right, using our power rule, we got negative 1 times 1 minus x, now to the negative 2 times derivative of the inside. So those negatives are going to cancel out. I'm going to get 1 over 1 minus x squared. Right, so my first derivative at 0 is also going to be 1. Okay, so I have my first 2 non-zero terms ready to go. So my second derivative, okay, so that's going to be negative 2 times 1 minus x to the negative 3 power times chain rule, so derivative of the inside, that's going to give me 2 over 1 minus x cubed. Hopefully we can start to see a pattern here. Right, so my second derivative at 0 is going to be 2 over 1 cubed, so that's 2. That's my third term, so to get one more term, I'm going to need my third derivative. So that's going to be, let's see, negative 6 times 1 minus x to the negative 4th times derivative of the inside, so 6 over 1 minus x to the 4th. And when I evaluate that at 0, right, that's 6 over 1 to the 4th, so just 6. Right, so we have all of our terms, so I'm going to write my Maclaurin series. So that means that the function 1 over 1 minus x is going to equal, right, we have our first derivative, our first term is f of 0, so 1 plus 1 times x. Since we're centered at 0, I don't have to do like the x minus c thing. Right, plus, okay, now I'm at my second derivative, that's 2, so that's going to be 2x squared over 2 factorial, plus, we got, now our next term is going to be 6 times x cubed over 3 factorial, plus, so those are our first 4 terms, and putting the general term together for this might be hard if we don't actually simplify first, because how are you going to figure out that number in front of it if you're not sure what's happening, right? So if we simplify this, we get 1 plus x plus, so 2 factorial is equal to 2, and 3 factorial is equal to 6, right? So the denominators actually are going to be canceling out with our numerators. So if we continue that pattern now, right, we can see that, right, it's just plus x to the n power is going to be our general term. And if we wanted to write that as a summation, we would start at n equaling 0 to infinity, and it would just be that this is x to the n power. So this function 1 over 1 minus x is this really basic power series where it's just equal to the sum of x to the n, right? There's no extra sequence in front of it. So this is pretty useful, and this comes up a lot on the AP exam because it's a very easy one to recognize and to manipulate. So we're going to go through some examples of how to manipulate this one, so how to change it a little bit to match different functions and some different calculus techniques that we can use with this. So let's formally define that. So this is what's called a geometric power series, and it's called this because it comes directly from the fact that the sum of a geometric series is the first term divided by 1 minus that ratio. And in this case, for this function, if we make the first term of the sequence 1 and the ratio equal to x, we get exactly the function 1 over 1 minus x. So that's where it comes from. You can also get this series by showing, by doing some long division and seeing how it turns out. So you can always try that out as well. So we're going to find the power series for 1 over 1 plus x at c equaling 0. So we're going to find the Maclaurin series, and now 1 over 1 plus x looks a lot like 1 over 1 minus x. The only difference is that it's a negative. So we know that 1 over 1 minus x, we just found that that power series is 1 plus x plus x squared plus x cubed plus our general term, x to the n. Right? So 1 over 1 plus x is the same thing, except if you want to write it as 1 minus, right, we want to subtract negative x. So all we're going to do here is we're going to substitute negative x in everywhere we see an x in the original. So we're going to get 1 plus negative x plus negative x squared plus negative x cubed, right, all the way out to our general term for negative x to the n power. So if we simplify this, we get 1 minus x plus x squared minus x cubed plus. So by doing this right now, all of a sudden we have an alternating series where we're going negative, positive, and that's going to continue because every time we raise negative x to an even power, right, the negative is going to cancel out. But if we have negative x to an odd power, now we have a negative term. So this actually just turns into, whoops, did not think I was still on my highlighter tool, right? This actually just turns into an alternating series. And I don't know why I wrote that so high up. I kept thinking it was going to be a fraction. It's not a fraction, right? So we need to figure out what exponent to put on the negative 1 so that way the sign pattern continues. So remember, we start with n equaling 0 typically, right? And this is n equaling 1 and so on. Right, so if I plug in 0, I want to get a positive. If I plug in n of 1, I want to get a negative. So I'm just going to make this to the n power, right? Or you can just keep this as negative x to the n power. That works too. You don't have to split it out if you don't want to. So we can also write that as the summation from 0 to infinity of negative 1 to the n times x to the n. And I'm just going to write it like that because sometimes it's nicer to have the alternator kind of split away. So the question also asks us to find the interval of convergence. So we're going to go ahead and add a new page because I'm out of space to do that. So, right, to find our radius of, we have to find the radius of convergence before we can find the interval. So we need to do our ratio test. Right, so we're going to do the limit as n goes to infinity of the absolute value of negative 1 to the n plus 1 times x to the n plus 1, right, over the original sequence. And that just equals, right, the negatives are not really going to matter. This is just the limit of n going to infinity of the absolute value of x, and that just equals the absolute value of x. And we know for the ratio test, that converges when it's less than 1. Right, and since this was a Maclaurin series, right, we had a c equaling 0, which means that we want x minus 0 to be less than r, or just the absolute value of x to be less than r. So this tells us that our radius of convergence is equal to 1. So we're centered at 0. So if we're thinking about a number line, we have our c value at 0, and I'm going to go 1 to the left. I'm sorry, that's the right, and 1 to the left. And now we just have to test the endpoints, right? So if we test the endpoints, right, we're going to get the sum. So I'm going to test we'll test negative 1 first. If I plug in negative 1, I'm going to go from n of 0 to infinity. And right, if we look back at the original, I get negative 1 to the n times x to the n. But that becomes negative 1 to the n. Right, and if I have negative 1 to the n times negative 1 to the n, exponent rules tell me that's 2n. Right, and 2n is always even, and negative 1 raised to an even power is always even. Is always positive. Right, so I'm really just adding up 1 an infinite number of times. So this diverges, right, by the nth term test because the limit of 1 as n goes to infinity is 1, which is not 0. Okay, so we know that for our interval of convergence, which I'm just going to say, start over here, IOC, interval of convergence, we know it doesn't include negative 1, and now we just have to determine the positive 1. So now if I test x is positive 1, I get the sum from n equaling 0 to infinity of negative 1 to the n times 1 to the n, right? So 1 to the n doesn't even matter because it's just a 1. Right, we can write it though if we want. Right, and we know that this is also going to diverge by the nth term test because negative 1 to the n is oscillating, so the limit does not exist. And since the limit does not exist, it automatically diverges. Right, if we want to be a little bit more specific, we could say the limit as n approaches infinity of negative 1 to the n does not exist. Right, up here we would have said limit as n goes to infinity of 1 is equal to 1, and that does not equal 0. Right, so we're also not going to include this guy over here. So there we go. I think we got one more slide here to go over, so probably one more problem. Oh, yeah, there it is. Right, so what about if it looks a little bit more different than that? So we want to find the power series for 1 over 4 plus x at c equaling 0. We're going to do the same thing, find the interval of convergence, and we're going to find the first 4 non-zero terms and the general term. So I always like to start by writing out my original, right? Because the more we write them out, the better we remember them. And then that way we don't have to keep things straight in our heads, which can get confusing when you're doing so much calculus, right? So I want to find 1 over 4 plus x. So the first thing I want to take care of is I want to get rid of the fact that there is a 4 there, right? So I kind of want to think about, maybe this time I'm going to actually work backwards to see if I can make this into the original so we can kind of see what the substitutions are. So I'm going to first factor out a 1/4. All right, so if I factor out a 1/4, this becomes a 1 and this becomes x over 4. Okay, so we're a little closer now because we have now the 1 and the 1. And now I need to get it to be a minus sign in between. So just like the last one, I'm going to leave that as 1/4 on the outside, but I'm going to make this 1 minus negative x over 4. So now I have the minus sign as well. Right, so now it kind of matches that format of the original sequence. So to do my substitutions, what I'm going to have to do is I'm going to say, okay, I have a 1/4 on the outside, so I'm going to be multiplying my whole sequence by 1/4, and at the same time, I'm going to be substituting in with negative x over 4. So I get 1 plus negative x over 4 plus negative x over 4 squared right, going all the way out to our general term here with our substitutions. Okay, so if we simplify a little bit, let's see what happens. So we still have that 1/4 on the outside, get 1 minus x over 4 plus x squared over 4 squared, right, minus x cubed over 4 cubed plus, right, we got negative x to the n over 4 to the n. And you're going to see why I'm writing it like that in a second. So if I think about distributing through with my 1/4, right, I get 1/4 minus, and that's 4 to the first there, right? So if I multiply by 1/4, I'm just putting an additional 4 into the denominator. So now this becomes x over 4 squared plus x squared over 4 cubed, right, minus x cubed over 4 to the 4th, right? So if I take that out to my general term, the numerator is not changing, but now my 4 is going to have a power of n plus 1, right? And we can also write that as the summation from 0 to infinity, and we're just going to put our general term in there. So negative x to the n over 4 to the n plus 1. So we found the first 4 non-zero terms in the general term, so we're done with that part of the question. And I wrote small enough that now we can actually go over and do our ratio test on the same slide without having to add anything. So I'm just going to put this over here so it's easier to see. And we had, that was our function 1 over 4 plus x equals that. So to find that interval of convergence, we know we need the radius, so we need the ratio test. Right, so we got the limit as n goes to infinity of the absolute value of negative x to the n plus 1 over 4 to the n plus 2, right, if I plug in n plus 1, times the reciprocal of that for the original. Now the absolute values are going to take care of those negatives, so I'm going to drop the negatives out. So I'm going to end up with x over 4, right? And so the limit of x over 4, the absolute value of that as we go for n to infinity, that's just the absolute value of x over 4. Remember, for the ratio test, we want to be less than 1. So since we're centered at 0, we just want the absolute value of x by itself. So I know that the absolute value of x over 4 has to be less than 1. Well, that tells me if I multiply both sides by 4, the absolute value of x has to be less than 4. So that means that my radius of convergence is going to be equal to 4. So for my interval of convergence, right, we're looking at the number line. We're starting at c of 0, and we go 4 to the right and 4 to the left. So I need to figure out if I'm going to put brackets or parentheses here. So we need to test our endpoints. Trying to line everything up. Okay, so I'm just going to put our little sequence down here again. Okay, so if I test x, let's test x of -4 first. I always start from left to right. That's just how my brain works. Okay, so I'm going to split the negative off, right? So this is the same thing as -1 to the n times x to the n. Actually, nah, we're not even going to do that, right? You consider that if you want to, but you don't have to. So if I plug in -4, I'm going to end up with +4 to the n over 4 to the n plus 1. And if I simplify that, right, I get 1/4. And that's going to give me, right, that's not going to help me at all. So the limit, right, the limit as n goes to infinity of 1/4 is equal to 1/4. And since that does not equal 0, right, that diverges by the nth term test. Right, so we know on our interval of convergence, we're going to put a parenthesis here. And then we're going to test the other one. So we got to test +4 as well. So if x is +4, we get the sum from n equaling 0 to infinity. And now I'm going to split off that -1 part. Right, so that's going to equal the sum of n equaling 0 to infinity of -1 to the n over 4. And again, that's also going to diverge by the nth term test because the limit of -1 to the n over 4, right, that limit doesn't exist because it's oscillating back and forth between -1/4 and +1/4. And since the limit does not exist, right, this also diverges, diverges by the nth term test. Which means that we're also not going to include the +4 on our interval